Welcome to Designfusion's Solid Edge blog. In this release, we will be looking at how to use the Excel file option on the Gauge tab in sheet metal design. Currently, if you set the material thickness to 10 gauge aluminum, it will change the material thickness for all 10 gauge material types. In reality, the material thickness is unique for each material type. The Use Excel table option on the gauge table allows you to specify that you want to get the gauge information from a custom Excel file. The Excel can be set up to contain unique sets of user-defined gauges for each material type. This combines with the Use Neutral Factors from Excel file option, which specifies that the neutral factor information is extracted from the Excel file. Solid Edge delivers a default Excel template named gagetable.xls, which you can use and customize to your needs. This file is in the Solid Edge Preferences folder and contains 3 predefined materials. The following slides will introduce you to the delivered Gauge Table Excel file. The Gauge Table Excel file contains a key which defines the start and end of the specific areas of the table for each material type. This is illustrated here on the slide. Each material type is defined as a new worksheet in the Excel file. The units for each material type are specified at the top of each worksheet. All gauge information on that worksheet must use the same units. For example, all gauges defined on steel 01 use inch values in the table, while all gauges defined on aluminum 6061 use millimeter values in the table. Remember, you can customize this table to suit your needs. You can define the material thickness, bend radius, relief depth, and relief width for each gauge size created. It's important to note that material thickness, bend radius, relief depth, and relief width cannot be overridden if a gauge table is being used, as this is defined in the table. Table values from the table are displayed in the dialog but are ghosted out. The gauge table can also be used to define the neutral factor based on the material type, the bend radius, and the bend angle. It's important to note that the neutral factor extracted from the gauge table for the individual bends is not actually applied to the model until it is flattened. So you will not see any change to the bent state of the model when changing these values in the table. The default sheet metal gauge table file location is set in an entry in the Solid Edge Options, File Locations. This enables a company to make a standard gauge table file in a central location that all engineers in the company would point to when specifying a material for a new design. Gauges may be changed globally to affect change in all associated parts. After you have created the gauge table and gauges, you can use the Associate with Material option on the Gauge Properties tab. This option associates the gauge table with the material specified in the field. The button is enabled when the Use Excel file option is selected, a gauge table is selected in the Use Gauge table, and a material is selected in the Material tab. When you select this option and click the Save button, the gauge table is associated with the material in the Material library. After the table is associated in the material library, when the same material is applied to another file, the associated gauge table is automatically used. For more information, see Map a Gauge File and Gauge Table to a Material or Document section in the Help documents. To better understand the Excel gauge table, let's have a look at this in Solid Edge. To demonstrate the user-defined Excel gauge table, we'll use this sheet metal part file. Notice this model contains different bend sizes and angles. Let's open the material table. Notice that the material currently assigned is aluminum 6061. We'll change this to 18 gauge. Notice that the Gauge tab is currently set to use a neutral factor of 0.33, which is the default setting. Let's apply this to the model. Next, let's open the existing flat pattern, which will be updated with the slight changes that we made to the model. Notice that the overall sheet size needed is 240.94 millimeters by 125.17 millimeters. Let's return to the formed model and reopen the Material Table's Gauge tab. This time, let's toggle on the Use Excel file option. Notice that a file is listed in the field beside this option. This file can be found in the Program Files, Siemens, Solid Edge 2025, Preferences folder and is named gagetable.xls. If we open this file, we'll notice that it's a multi-tabbed Excel file. The first tab provides information on the file. Each other tab is a material tab containing the material information used for flattening the model. For example, the next tab is steel. This tab contains all the information required for calculating a flat pattern for specific steel gauge sizes for models using inches as their units. The next tab is for aluminum 6061 material. Notice that the millimeter units are defined at the top of the page, followed by multiple sections containing the gauge name header, the material thickness, bend and relief properties, and a neutral factor table, which is based on the angle and radius of the bend. If we scroll down, we'll notice that the tab is set up for 10 gauge, 20 gauge, and 18 gauge. The next tab is set up for several gauges of stainless steel. This is the delivered file which companies can edit to suit their specific needs, based on the material, gauges, and desired neutral factors. Let's return to our Gauge tab. Notice that with the table selected, we can select the specific tab that we want to use from the Excel file. We can then select the specific gauge. Notice that in the bend equation section, the option Use Neutral Factor from Excel file has been automatically toggled on. We can then apply this to our model. It's important to note that the settings in the table do not affect the model bend values. These remain the same size in the formed model. The table values are only used in the creation of the flat pattern. Let's open the flat pattern again and notice that the overall sheet size needed is now 242.25 millimeters by 125.1 millimeters. Slightly different from the original size because we refined the neutral factors used to calculate the flat pattern. Let's return to the Gauge tab to point out one other option. Let's reset the table options and then notice the Associate with Material option. When you select this option and save it after applying it to the model, the Gauge table is associated with the material in the material library. After the table is associated in the material library, when the same material is applied to another file, the associated Gauge table is automatically used. Let's open the Solid Edge options and go to the File Location folder. Companies may choose to use a central gauge table for all their uses. If so, they can store this file on a central server and define the file's location here. Want to learn more? Sign up to our customer portal at the website shown on this slide, where you have access to knowledge-based articles, tips and tricks, how-to articles, and much more. If you require additional support, you can contact our support team at support@designfusion.com or call us at 1-877-2151-883.